Class, division, and group designations are used to classify hazardous locations for electrical equipment. Class indicates the type of hazardous location where the equipment is intended to be used. Division subdivides the hazardous location class into levels of hazard. Lower division numbers indicate greater hazards. Group classifies the hazardous materials present in a location. Let's break down how to interpret these references on certification records. Consider the reference Class 1, Groups A, B, C, and D. This indicates that the equipment is approved for use in Class 1 hazardous locations. Class 1 refers to areas where flammable gases or vapors are present. The groups A, B, C, and D specify the particular gases or vapors that the equipment is suitable for. This approval applies to both Division 1 and Division 2 hazardous areas within these groups. If a piece of equipment is listed as Class 1, Division 1, Groups A, B, C, and D, this means the equipment is specifically approved for use in Class 1, Division 1 hazardous areas. Division 1 areas are those where flammable gases or vapors are present in sufficient quantities to ignite and propagate a flash fire under normal operating conditions. Importantly, approval for Division 1 does not automatically imply approval for Division 2 areas. Now consider Class 1, Division 2, Group D. This indicates the equipment is specifically approved for use in Class 1, Division 2 hazardous areas. Division 2 areas are those where flammable gases or vapors are not likely to be present in sufficient quantities to ignite and propagate a flash fire, but are likely to form explosive mixtures under abnormal conditions. Approval for Division 2 does not imply approval for Division 1 areas. A crucial aspect not mentioned in the provided certification record is the temperature class. The temperature class, sometimes referred to as a T rating, indicates the maximum surface temperature that the equipment will reach during operation. It's essential to ensure that the equipment's temperature class is below the ignition temperature of the surrounding hazardous materials. The absence of a temperature class on the certification record could mean one of two things. Firstly, the equipment is suitable for a wide range of temperatures, or secondly, the specific temperature class is not applicable to the hazardous location classifications. In such cases, further investigation might be required to determine the temperature suitability of the equipment. To recap, firstly, class defines the type of hazardous environment. Secondly, division indicates the likelihood of the hazardous material being present and the associated risk. Thirdly, group specifies the particular hazardous substance. Always consult the equipment certification documentation and relevant safety standards to ensure proper selection and installation for the intended hazardous location. When selecting equipment for hazardous locations, it's crucial to consider several factors, including the specific class, division, and group requirements, as well as the temperature rating. Different hazardous locations pose different risks, and it's essential to choose equipment that is designed and certified to operate safely in those conditions. The National Electrical Code, or NEC, provides detailed guidance on the installation of electrical equipment in hazardous locations. Article 500 and subsequent articles in the NEC cover the requirements for different classes, divisions, and groups. The NEC also specifies the types of wiring methods, seals, and other protective measures that must be used to prevent explosions and fires. In addition to the NEC, other standards and regulations may apply depending on the specific industry and location. For example, the Occupational Safety and Health Administration, or OSHA, has regulations governing the use of electrical equipment in hazardous locations. It's important to be familiar with all applicable standards and regulations to ensure compliance and prevent accidents. Proper installation and maintenance are also essential for ensuring the safety of electrical equipment in hazardous locations. Equipment should be installed according to the manufacturer's instructions and inspected regularly for signs of damage or deterioration. Any damaged equipment should be repaired or replaced immediately. It's also important to ensure that all wiring connections are tight and that all seals are properly installed to prevent the ingress of flammable gases or vapors. Training is another important aspect of electrical safety in hazardous locations. Workers who install, maintain, or operate electrical equipment in hazardous locations should be properly trained on the hazards involved and the safety precautions that must be taken. Training should cover topics such as the classification of hazardous locations, the selection and installation of appropriate equipment, and the proper use of personal protective equipment. In conclusion, understanding class, division, and group designations is crucial for selecting and installing electrical equipment in hazardous locations. These designations provide a framework for classifying hazardous environments and ensuring that equipment is designed and certified to operate safely in those conditions. By following applicable standards and regulations, and by providing proper training and maintenance, it's possible to minimize the risk of explosions and fires and protect workers and property. Consider a scenario where a manufacturing plant uses flammable solvents in its production process. The plant has several areas that are classified as Class 1 hazardous locations due to the presence of these solvents. Some areas are designated as Division 1 because the solvents are frequently present in the air during normal operations. Other areas are designated as Division 2 because the solvents are only present under abnormal conditions such as leaks or spills. To ensure safety, the plant must use electrical equipment that is specifically designed and certified for use in these hazardous locations. In the Division 1 areas, the equipment must be explosion-proof, meaning that it is designed to contain any internal explosion and prevent it from igniting the surrounding atmosphere. In the Division 2 areas, the equipment can be either explosion-proof or non-incendive, meaning that it is designed not to produce sparks or hot surfaces that could ignite the flammable solvents. The plant must also follow strict procedures for installing and maintaining the electrical equipment. All wiring connections must be tight, and all seals must be properly installed to prevent the ingress of solvents. The equipment must be inspected regularly for signs of damage or deterioration, and any damaged equipment must be repaired or replaced immediately. In addition, the plant must provide training to its workers on the hazards of working in hazardous locations and the safety precautions that must be taken. Workers must be trained on the proper use of personal protective equipment, such as respirators and flame-resistant clothing. They must also be trained on how to respond to emergencies, such as leaks or spills. By following these procedures, the manufacturing plant can minimize the risk of explosions and fires and protect its workers and property. The class, division, and group system provides a clear and consistent framework for classifying hazardous locations and ensuring that electrical equipment is selected and installed appropriately. This helps to create a safer working environment for everyone. Let's further elaborate on temperature class, often indicated by a T code. This code signifies the maximum surface temperature the equipment will reach during operation. It is imperative that this temperature remains below the auto-ignition temperature of the surrounding flammable substance. Common T codes include tone T2, T3, T4, T5, and 6. A low number indicates a higher surface temperature. For example, a 6 rating means the equipment surface temperature will not exceed 85 degrees Celsius, while a tone rating allows for a surface temperature up to 450 degrees Celsius. When selecting equipment, you must consult tables that list the auto-ignition temperatures of various flammable substances. The equipment's T-code must be chosen so that its maximum surface temperature is significantly lower than the auto-ignition temperature of the gas or vapor present. Furthermore, consider the impact of ambient temperature. The T-code is usually specified for a particular ambient temperature range. If the equipment is to be used outside of this range, the T-code may need to be adjusted accordingly. Always refer to the manufacturer's documentation for guidance on derating T-codes for elevated ambient temperatures. The NEC provides tables, specifically in Article 500, that guide the selection of appropriate equipment based on the class, division, group, and temperature rating of the hazardous location. These tables are essential for ensuring compliance with safety standards. Proper documentation is also crucial. Maintain detailed records of all equipment installed in hazardous locations, including their certification details, T-code, and installation dates. These records should be readily available for inspection and maintenance purposes. Regular inspections are vital. Establish a routine inspection schedule to check for signs of damage, corrosion, or other issues that could compromise the safety of the equipment. These inspections should be performed by qualified personnel who are familiar with hazardous location safety requirements. Consider using a checklist to ensure that all critical components are inspected thoroughly. Maintenance is equally important. Follow the manufacturer's recommendations for maintenance and repairs. Use only approved replacement parts and ensure that all repairs are performed by qualified personnel. Any modifications to the equipment must be approved by a certified testing laboratory. Let's explore some specific examples. Suppose a chemical plant uses acetone, which has an auto-ignition temperature of 465 degrees Celsius. The plant has areas classified as Class 1, Division 1, Group D. In these areas, the equipment must have a T-code of at least tone to ensure that its surface temperature does not exceed 450 degrees Celsius, which is safely below the auto-ignition temperature of acetone. Now, imagine an oil refinery uses propane, which has an auto-ignition temperature of 450 degrees Celsius. The refinery has areas classified as Class 1, Division 2, Group D. In these areas, the equipment could have a T-code of T2, allowing for a maximum surface temperature of 300 degrees Celsius, which is still safely below the auto-ignition temperature of propane. Remember, the specific requirements will depend on the particular flammable substances present and the environmental conditions. Always consult the relevant safety standards and regulations for detailed guidance. In addition to explosion-proof and non-incendiary equipment, other protection methods are available for hazardous locations. These include intrinsically safe circuits, purged and pressurized enclosures, and oil-immersed equipment. Intrinsically safe circuits are designed to limit the amount of energy available in the circuit to a level that is too low to ignite a flammable atmosphere. Purged and pressurized enclosures use positive pressure to prevent flammable gases or vapors from entering the enclosure. Oil-immersed equipment submerges electrical components in oil to prevent them from coming into contact with the atmosphere. The choice of protection method will depend on the specific application and the type of hazardous location. Each method has its own advantages and disadvantages, and it's important to carefully consider all factors before making a decision. Safety barriers are also crucial. Use safety barriers to isolate intrinsically safe circuits from non-intrinsically safe circuits. These barriers prevent excessive energy from entering the hazardous location. Install grounding systems to minimize the risk of static electricity buildup. Static electricity can be a source of ignition in hazardous locations. Perform regular audits to ensure that all safety procedures are being followed. These audits should be conducted by qualified personnel who are familiar with hazardous location safety requirements. Keep abreast of any changes to safety standards and regulations. Hazardous locations safety is an evolving field, and it's important to stay up to date on the latest requirements. Attend training courses and seminars to enhance your knowledge and skills. Share best practices with colleagues and other industry professionals. Collaboration is essential for promoting safety in hazardous locations. In summary, navigating the intricacies of class, division, group, and temperature ratings requires a comprehensive understanding of hazardous location safety principles. By adhering to relevant standards, implementing proper installation and maintenance procedures, and providing adequate training, you can significantly reduce the risk of explosions and fires and create a safer working environment. Always prioritize safety and consult with qualified experts when necessary.